Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, so the 2017 question on coordinate geometry, the line from the Leaving Cert ordinary level course, the points A to 1, which is here, B 6, 3, C 5, 5, and D 1, 3 are the vertices, fancy word for corners, of the rectangle ABCD as shown. Show that AD is equal to root 5. Okay, so in that, let me just go back to coordinate geometry in my log tables. I'm gone the wrong way. Okay, so you have to know that that is maths language for the length of, okay? So watch out for those two lines and two letters between two letters being 2 points, and they're asking you in maths language for the length of, okay? The other clue in that question was the fact that it was root 5 as your answer, okay? So the length of AD, the length of any line, is the square root of, and I'm just taking down this formula here, x2 minus x1 ought to be squared plus y2 minus y1 ought to be squared. Okay, if it's AD that I am going to get the length of, I will take down the point A, which is 2, 1, label him x1, y1, take down the point B, which is 6, 3, label him x2, y2. Okay, if you forget how to label, make sure you use it up here. So then the length of AD then is, I'm going to sub in those values. So x2 is 6, x1 is over here. If you could read my writing, it's 2 ought to be squared plus y2, 3 minus y1 squared. Okay, you can work it out separately. You can put it all into the calculator. I tend to just put it all in. Oh, sorry, I'm getting the distance between A and B. No wonder I'm not getting no wonder I'm not getting root 5. Okay, so if I need the distance between A and D, then I obviously have to take the point D, which is 1, 3. Okay, x1, y1, x2, y2. So scratch what I just did there because I was getting the distance between A and B. Distance between A and D is x2 minus x1 squared plus y2 minus y1 squared. Okay, so like I was saying, you can put it all into the calculator in one go, or you can do it yourself separately. But either way, you should get root 5 for your answer. Okay, so that's that one done. Okay, that's you showing that the length of AD is equal to root 5. And you obviously leave it in third form. That's called third form with the square root sign. You don't convert it to a decimal because the question said root 5. Okay, find in square units the area of the rectangle ABCD. Okay, so area of a rectangle is length by width. Okay, you have just found out that the length of AD is root 5 or BC is root 5 because it's a rectangle. So I need to find the length of AB. I should have kept going when I was going. Okay, so if it's going to be AB then that I find, I take down A, I take down B, I label them x1, y1, x2, y2, and I get the length of AB. So it's the same formula. So x2 is 6 minus x1, which is 2 squared, plus y2 minus y1 squared. Okay, put that into your calculator with the right values. And you get root 20 or 2 root 5. So I'm getting 2 root 5 when I put that into the calculator. Okay, so find in square units the area. So the next bit I go is area is equal to length by width or length by breadth, whichever you call it. So it's root 5 multiplied by 2 root 5. So try not let the thirds bit bother you. And I am getting 10 units squared or 10 square units. Okay, find the equation of the line BC. Okay, so find the equation of this line here, BC. Okay, give your answer in the form ax plus by plus c is equal to 0. So try not let that line put you off at the start. Concentrate on your task, which is find the equation, because that bit that I've coloured in yellow is literally just the order that they want the answer in, as opposed to how do I do it. So when you're told to find the equation, come over here for equation. The top one is what we use to find an equation. The second one is when they give us an equation. But the top one is to find an equation. So you are going to go for this one, y minus y1 equal m times x minus x1. Okay, that is how we find the equation of a line. Now we need to find the equation of the line BC. So B is 6, 3. C is 5, 5. So to find any equation of a line, we need to find slope and we need this point, x1, y1. And x1, y1 can be either point because it's just one point. You can pick either one, and then y stays y and x stays x because you're finding an equation, and equations always have x's and y's in them. But the first job you have to do is to find slope. So some questions are nice in that there would be a part before this that says find the slope. But this question didn't do that. So it's up to you first to find the slope, which is y2 minus y1 over x2 minus x1. Where am I getting that from? I'm getting it from here. So the slope, y2 minus y1 over x2 minus x1. Okay. So label them just like you would any other one, x1, y1, x2, y2, and sub them in. So m is y2 minus y1 over x2 minus x1. Okay, on your calculator, hit your fraction button and go 5 minus 3, and on the bottom, 5 minus 6. Okay, and I am getting a slope of minus 2 for that. So what I always do is I check, does a minus slope make sense? So a minus slope always means my line is coming downwards. So it's a negative slope, okay? So I found the slope of BC or CB. So from left to right, can you see that line is coming down? So a negative slope does make sense. Okay, so happy that I've done that right, and then let's sub them in. For my x1, y1 point, I'm just going to use this one that I've called x1, y1. So I get y, so I'm subbing it into here now. Okay, y minus y1 is equal to my slope times x minus x1. Just in algebra, get rid of the brackets by multiplying in, and then merge the two numbers. So plus 3 to both sides, if that's how you do it. Y is equal to minus 2x plus 15. Okay, so that's a perfectly acceptable answer. Okay, but it's just not in the order they wanted. So they wanted the x's first, then the y's, then the numbers. Okay, so let's give them what they want. Let's bring everything over this side. Okay, and write them together. So if I bring minus 2x over to the left, it travels over the equals to sign, so it changes sign. That's my x's first. The y is already on the left of the equals to sign, so I leave it on the left. The plus 15 comes over and it becomes minus 15 equals 0. So that now is in the form ax plus by plus c equals 0. Okay, A is just a number, B is just a number, which is 1, and C is minus 15. Okay, so it's just the order they wanted them in. Now, a good question to ask is, how do you know which side do you bring letters over? So could I have brought Y over this side, for example? Well, the answer is yes, you can. Okay, you can go either side. You just have to bring everything over to the one side. So if you had brought the Y over, you would have had minus 2x plus Y would have come over and be minus Y, and he would have stayed plus 15 is equal to 0. And if you compare the answer I got when I brought everything to the left with the answer you would have got if you brought everything to the right, you'd see they're the exact same, apart from the signs are all different. And the signs are all different because we're on opposite sides of that equals to sign. In fact, they're the same equation. They're just the mirror image of each other. And I call it a mirror image because if you look into a mirror, you see yourself, but opposite sides. Okay, so that's what's happening here. So either way, I tend to bring it to the side that makes my x term positive. So that is why I chose to bring everything to the left, but it doesn't matter which way you do it. Okay, now the last part of that question, I'm just going to go onto a new page because I'm running out. And let me copy this piece. Use trig to find the measure of the angle ABD. Give your answer correct to the nearest degree. Okay, so I'm also going to come back here and I'm going to take the diagram. So diagram is always good. Okay, use trig to find the measure of the angle ABD. Okay, so ABD. Okay, so that is the angle ABD. Okay, give your answer correct to the nearest degree. Use trig. Okay, so if I go to the log tables and I go to trig, okay, so on your course is right angled trig. So this is all I have to answer any right angled trig question. So I can use sine, I can use cosine or cos, and I can use tan, or I can use Pythagoras' theorem. Okay. Do I know any information about this triangle? Okay, well, yes, I do. I have the length of AD here. And I have the length of AB. So this one is root 5, and this is 2 root 5. Okay, so that's, I suppose, what I know about them. Does the points make sense in trig? The fact that I have all these points? No, it doesn't. So none of these points up here are any good. They're no good for the trig chapter. So trig is all about lengths of sides and angles. So there's 6 pieces of information that's good in trig. There's 3 angles, one here, one here, one here, and 3 sides, one here, one here, one here. Okay, and that's all you have in trig. We're told to find an angle, right? So I want to talk to you a little bit about Pythagoras' theorem. Pythagoras' theorem is all about sides. So if you see it's written with small letters, c squared is equal to a squared plus b squared. And in the log tables, you can see the small letters are all the sides because the log tables uses capital letters for angles. So Pythagoras' theorem tells me that the hypotenuse squared is equal to the other 2 sides squared. That's no good to me for finding an angle. Okay, so all I have left is sine, cos, and tan. Right, so how am I going to use them? So I'm hoping you have some sort of a rhyme. I am a silly old Harry, caught a herring trawling off America. Or the other one I tend to use is oh hell, another hour of algebra because it's an easy one to remember. But you have to remember that the order out here is sine, cos, and 10. Okay, so it doesn't matter which one you remember. Okay, you then label your sides. So if I'm to draw that triangle, I find it awful handy to just draw the triangle for myself rather than use the diagram in the question, because then I can eliminate anything I don't care about, such as the rest of the rectangle, such as this detail here, because it doesn't matter for trig. Okay, and that's my angle. Okay, so let's label. So my right angle is here, which means the side opposite your right angle is always your hypotenuse. The side opposite your angle in your question is always opposite, and the one beside, or the last one left, is called adjacent. Adjacent is another word for beside. Okay, so that's my sides labelled. Tick, that's that job done. That's my rhyme written down. Tick. So in any trig question, that is how I will always start it. Label the sides, write down sine, cos, tan. Okay, now which one is it? So you look at what information you have. So if I need that angle, I'm going to use opposite because I know what length it is, and I'm going to use adjacent. I know nothing about the hypotenuse, so in fact, that's no good to me. So which one links opposite with adjacent? There's my O, there's my A. Okay, so tan of that angle that I'm just going to call X is equal to opposite over adjacent. In my one, that tan of that angle is opposite over adjacent. Okay, and you can put that into your calculator if you want. I'll do that here. So root 5 over 2 root 5, and I'm getting a half. So now I have tan x being equal to a half. Okay, now I want x the angle. I don't want tan of x. Okay, so in an ideal world, I'd like to get rid of this tan business. Okay, so I want just the angle is equal to so many degrees. How do I get rid of tan? Well, you get rid of tan by doing the opposite of tan, which is tan inverse. Okay, so you get tan inverse here, tan inverse here, tan and tan inverse cancel. So you're left with just x the angle. What I do to one side though, I had to do to the other. That's why tan inverse appears on the other side. Okay, so put into your calculator then tan inverse, and tan inverse sits behind tan, so you'll need to use the shift button. Tan inverse of a half. And I'm getting 26.565 degrees. And then it said to the nearest angle, well, 0.56 rounds it up. So 27 degrees is the nearest angle. Okay, so watch out for the little bit of trig at the bottom of the coordinate geometry question. It's not unusual that it appears. So that was the 2017 question.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in electronics and self-driving technologies, and from there to the Masters.
Check out the link below for more information.